Where the solar system really ends is not where most people think it ends. It is not Pluto. It is not Neptune. And it is not the last place sunlight can reach. The real edge is stranger than a border. It is a fading zone of frozen worlds, invisible forces, and objects so distant that some of them may remember the birth of the sun. For most of modern history, the solar system looked simple. There was the sun at the center, then Mercury, Venus, Earth, and Mars, then the asteroid belt, then the giant planets, and after Neptune, there was Pluto, a tiny frozen world moving through darkness. For decades, Pluto felt like the final marker on the map, the last familiar name before empty space, the place where the solar system quietly ended. But that map was wrong. Pluto was not the end. Pluto was the warning sign. Because beyond Neptune, scientists began to find something much larger. Not a single lonely planet, not a clean outer wall, but a vast ring of icy bodies wrapped around the sun. This region is called the Kuiper Belt, and it changed the meaning of the edge forever. The Kuiper Belt begins beyond Neptune, roughly 30 times farther from the sun than Earth is. It stretches outward for billions of kilometers, filled with frozen objects left behind from the earliest days of the solar system. These are not just rocks. They are ancient leftovers. They formed when the planets were still being built, when the young sun was surrounded by dust, ice, and chaos. Most of that material was swept into planets, moons, or thrown away by gravity. But some of it survived. Out beyond Neptune, in the cold, dim borderlands, pieces of the old solar system remained almost untouched. That is what makes the Kuiper Belt so important. It is not just a place. It is a fossil field, a frozen archive of what the solar system looked like before Earth had oceans, before life existed, before anything human could look up and wonder where the edge was. And then comes the strange part. For a region this enormous, we discovered it shockingly late. Pluto was found in 1930, but the wider Kuiper Belt was not confirmed until 1992. That means humanity mapped galaxies, landed on the moon, sent probes to the planets, and still did not fully understand the region right outside Neptune. The edge of our own solar system was hiding in plain sight. And once astronomers found it, Pluto began to look different. It was no longer the lonely ninth planet. It was one member of a much larger population, a famous one, a strange one, but not alone. Other icy worlds began to appear. Some were large enough to challenge Pluto's status. One of them, Eris, was so important that it helped force astronomy to ask a painful question. What is a planet? That question led to Pluto being reclassified as a dwarf planet in 2006. To many people, it felt like Pluto had been demoted. But scientifically, something bigger had happened. Pluto had not become less interesting. The solar system had become more crowded. The old picture was gone. The edge was not one planet. It was a belt of frozen worlds. Then, New Horizons arrived. Launched in 2006, the spacecraft crossed billions of kilometers to reach Pluto in 2015. Before that moment, even our best images of Pluto were blurry. It was a small smudge at the edge of vision. Then the pictures came back, and Pluto was not dead. It had mountains, glaciers, a thin atmosphere, a bright heart-shaped plain, a surface that looked younger than anyone expected. This was supposed to be a frozen relic, locked in darkness for billions of years. Instead, it looked active, complex, alive in a geological sense. That was the first shock. The second came after Pluto. New Horizons kept going deeper into the Kuiper Belt. On January 1st, 2019, it flew past a small object called Arrokoth. Arrokoth looked like two icy bodies, gently pressed together, like a relic from the solar system's construction site. It was not dramatic in the way Jupiter is dramatic. It had no giant storm, no rings, no volcanic moon. But it may have been more valuable. Because Arrokoth looked ancient, not destroyed, not reshaped, not melted down and rebuilt. It looked like something that had survived from the beginning. And that is the terrifying beauty of the Kuiper Belt. It is not empty, it is quiet. There is a difference. Empty means nothing is there. Quiet means something is there. But it has been waiting for a very long time. Out in the Kuiper Belt, sunlight is weak. The sun is no longer the blazing object we know from Earth. It becomes a distant white point. Still powerful, but emotionally smaller. The warmth is gone. The planets are behind you. The familiar solar system begins to feel like a memory. And yet, even here, this is still not the true end. That is where the story turns again. Because the Kuiper Belt may feel like the edge, but it is only one edge. The solar system has more than one boundary. There is the edge of the planets. There is the edge of the Kuiper Belt. There is the edge of the sun's magnetic influence. And far beyond that, there may be the Oort Cloud. The Oort Cloud is not like the Kuiper Belt. The Kuiper Belt is more like a thick, icy ring beyond Neptune. The Oort Cloud is thought to be a vast shell surrounding the solar system from every direction. A sphere of icy bodies so distant that it may stretch a quarter of the way, or even halfway, to the nearest star. Think about what that means. If Earth is one step from the Sun, Neptune is about 30 steps away. The Kuiper Belt begins around there and stretches farther outward. But the Oort Cloud may begin thousands of steps away, and it may continue for tens of thousands more. This is where the scale stops feeling useful. The numbers become too large to imagine. The solar system is not a neat set of planets. It is a gravitational empire, and the sun's rule fades slowly. Not at a wall, not at a line, but across a huge region where objects are barely held by its gravity. Some comets may come from there. They spend most of their existence in deep cold, barely moving under the sun's distant pull. Then a passing star, a galactic tide, or a small gravitational nudge can disturb them. Suddenly, after millions of years in darkness, one begins falling inward, toward Neptune, toward Jupiter, toward Earth. A visitor from the outermost storage room of the solar system. But no spacecraft has reached the Oort Cloud. No telescope has directly mapped it as a complete structure. It remains one of the strangest ideas in astronomy. A border so large that even Voyager 1, the farthest human-made object ever sent from Earth, has barely begun the journey. And that brings us to another possible edge. The heliosphere. The sun is not just a ball of light. It constantly sends out a stream of charged particles called the solar wind. This wind blows outward in every direction, forming a giant bubble around the solar system. Inside that bubble, the sun dominates the space environment. Outside it, interstellar space begins to push back. The boundary where this happens is called the heliopause. Voyager 1 crossed it in 2012. Voyager 2 crossed it in 2018. For the first time, human-made objects entered interstellar space. But even that statement is more complicated than it sounds. Because Voyager left the sun's protective bubble, but it did not leave the sun's gravity. It passed one kind of edge, but not all of them. That is the problem with asking where the solar system ends. There is no single answer. If the solar system means the planets, it ends near Neptune. If it means the Kuiper Belt, it extends far beyond Pluto. If it means the sun's particle bubble, it ends at the heliopause. If it means everything gravitationally tied to the sun, it may reach into the Oort Cloud, almost toward the next star. So the real answer is unsettling. The solar system does not end cleanly. It dissolves. It fades from planets into dwarf planets, from dwarf planets into icy bodies, from icy bodies into scattered comets, from sunlight into darkness, from the sun's wind into the pressure of the galaxy. And somewhere in that fading darkness, there may be something large. For years, astronomers have noticed that some distant objects beyond Neptune move in strange ways. Their orbits seem clustered, almost as if something unseen is pulling them. One possible explanation is Planet 9. Not Pluto, not a reclassification. A real undiscovered planet, possibly larger than Earth, possibly far beyond Neptune, possibly moving so slowly around the sun that one orbit could take thousands of years. But no one has seen it, not directly. And that is what makes the outer solar system so disturbing. It is not just far away, it is hard to search. A distant planet would reflect very little sunlight. It would move slowly against a crowded background of stars. It could hide, not because it is small, but because the sky is enormous. We imagine discovery as a bright object appearing in a telescope. But out there, discovery is more like noticing one faint dot shift slightly after many nights of watching. A needle in a haystack. Except the needle is dark. The haystack is the sky, and the search area is almost beyond human instinct. Planet 9 may not exist. There may be another explanation, but the fact that it remains possible tells us something important. The outer solar system is still not fully known, not in the past. Now, in the age of space telescopes, Mars rovers, asteroid missions, and images from the edge of the observable universe, our own solar system may still be hiding a planet. That should change how we see the night sky, because the solar system is not a finished map. It is an active investigation. Every time we push the edge farther out, the edge moves again. Pluto was the end. Then the Kuiper Belt appeared. The Kuiper Belt was the edge. Then scattered objects stretched the story farther. The heliopause was the edge. Then the Oort Cloud made the solar system almost unimaginably larger. And beyond that, the sun is still moving. The entire solar system travels through the Milky Way, carrying its planets, moons, comets, dust, and human machines through interstellar space. Voyager 1 is out there now. So is Voyager 2. Their power is fading. Their signals are weak. Every message takes many hours to cross the distance between them and Earth. Eventually, they will fall silent, not because they stop existing, but because they will no longer have enough power to speak. After that, they will keep going. Silent machines from a small planet, carrying human fingerprints into a darkness no human eye has ever seen. And long after their last signal reaches Earth, they will still be moving through the outer reaches of the sun's domain. Past the planets, past the Kuiper Belt, past the boundary where the solar wind gives up, toward the deeper cloud of ancient ice, toward the place where the sun becomes just another star. That may be the real edge, not a line, not a wall, but the moment when our star stops feeling like home. The strange truth is that the solar system is much larger. older, darker, and less understood than the simple classroom diagram ever showed. The planets are only the bright inner story. The real border is written in frozen debris, invisible gravity, weak signals, and objects that take thousands of years to move once around the sun. So when people ask where the solar system really ends, the honest answer is this: we are still finding out. Thanks for watching. Do not forget to subscribe for more history mysteries.